This is topic 3C, and we're going to be discussing current electricity and the different components of circuits and how to measure current and resistance and voltage. Let's start off with current electricity. Current electricity is the flow of electrical charges, mainly the electrons that flow through a circuit. So the electrical energy is measured in something called joules, and electrons move randomly in any substance as pictured here. So even in your body, these electrons are moving randomly until a power source is supplied. That power source allows a positive and negative field, a positive and negative interaction that creates this electric field, which exerts a force on the electrons in the circuit. And when they have a force exerted upon them, then they are able to move only in one direction. So there's a little image here. The electrical current is the rate of movement of the electron charge, and this is similar to the rate of flow in water. So here's a little diagram to show you the similarities between water flowing through tubes and electrons flowing through a circuit. As you can see at the bottom, we've got the battery. That is the power source. On the left-hand side, where we're dealing with water, we've got the pump, and the pump ends up pumping the water to allow it to flow through the tubes and then into the turbine. And what does the turbine do? Well, it spins and it will generate some energy. And the energy is in any type of form. It could be converting it to electrical energy or heat energy. It all depends on what this application is used for. So water is pumped through the tubes into the turbine spins, creates a different type of energy, and then it goes down back into the pump and it essentially gets recycled. Now, in an electrical circuit, we've got the battery as a power source. Electrons flow from the negative terminal, the anode, all the way up into the light bulb through the little wires, tungsten wires in that light bulb, and it gives off heat energy as well as light energy. So there is some energy that is lost in here. The electrons reach back down into the circuit and they travel around into the battery, the positive terminal or the cathode of the battery. And this cycle goes on and over until the battery's juice is run out and electrons can't really pass through it anymore. We know that electrical charge that passes through a point, it's measured in terms of the number of electrons. But how do we classify the number of electrons? Well, we classify it as a coulomb. The next number is going to flash really quickly. The number for 1 coulomb is 6.25 times 10 to the power of 18 electrons. Electric current is measured in amperes, also known as amps. Now, if you're a musician, you do know what an amp is. It's like an amplifier. It amplifies the sound of music. So when you measure something in amperes, we are using an ammeter, and it tells us how many amps are in that electrical circuit. So 1 amp is exactly equal to 1 coulomb per second. So that means that in whatever given circuit you have, even if it's a tiny little wire, if it ends up being 1 amp, then the amount of coulombs in that per second, it translates to 6.25 times 10 to the power of 18 electrons going through that circuit within 1 second. That is crazy. That's mind-blowing. Now let's take a look at the types of electrical currents. There's a direct current, DC, and that is where the electrons flow in only one direction. So a great example of this is the battery, where the electrons flow from the negative terminal to the positive terminal. Or you can have an alternating current, which is where electrons move back and forth, switching directions. Here's a great example of that. Usually they are powered by generators, and those generators are cranked different ways in order to allow those electrons to flow either to the right or to the left in these diagrams. We call the types of electrical currents AC and DC. The one that is mainly used in your homes is the alternating current, and this is just because it's more efficient and it's more useful. You don't want to turn off one light in your house and have all the power go out. That would be a direct current. You want to be able to control what rooms are lit up, so you want an alternating current. What prevents too much electrical current from passing through a circuit and causing damage? The prime example of this is resistance. In resistance, electrons don't travel far before colliding with something else. It's the property of a substance that prevents the electrical current from moving through. And it also prevents fires or other hazards that may be caused by all of those electrons traveling or too many electrons traveling through a conductor. Because those wires, they will heat up if they're not insulated. And if those electrons have something to move to, they will. Resistors convert electrical energy into heat or light energy. A resistor is used to decrease the amount of current that travels by a specific amount. Now, silver is an excellent conductor with a very, very low resistance, but copper is generally used more often because it's cheaper. It is a great conductor as well. This is what a resistor looks like in a circuit that you will be building together. Just for your information, a little fact here, there are something called superconductors in which they possess no resistance whatsoever. And these are very, very efficient. In an example of like MRI machines or magnetic resonance imaging, hospital imaging machines. They require no resistance, and when they have wires with no resistance, it allows that electrical current to flow a little bit easier. Here's some examples of resistors. A load is considered a resistor. A load transforms electrical energy into either heat, motion, sound, or light. Here are some examples of resistors. A toaster oven, a light bulb, a room heater. These are all different types of loads that are classified as resistors as well, because some of that electrical current goes through the load and some of that energy is taken away. So it's given off and that energy just dissipates.